Hi, Bruno. Welcome back.
Hey Adam, yeah, thanks for having me. It's been a fun.
And I forgot, your last name is Borges, right? Is it perfectly pronounced?
Yeah, that's perfectly pronounced.
Really?
Borges. That
Borges.
is, yeah. Some people call me Borges, and all I can think of is cyborg, and it's weird. Borges is the right way.
Borges. You see?
Yeah, it's a
Um,
little bit German. I don't know. It sounds a little bit German.
the Borges name? Yeah, maybe it's a German. I thought it was a Brazilian, right? Portuguese.
Well, the way it's written out these days is, but when I did some research years ago, I found some traces of German-ish thing in the name.
Yeah, you have a German
The issue
humor.
of the
This
name.
is this is the traces, you know.
You say my humor is bad?
No, very good.
Jesus.
German humor. Just saying.
Yeah. Okay.
What I found, you changed the department, right? You were the Asia manager, and now you are back to Java, right? If I'm correct.
I was well. That it's been a while. When was the last time that we spoke?
I
Was
have
that
to
like?
check it, but it was 1 year for sure.
Oh, I was already in this team. Yeah, but yeah. I mean, if people are interested. When I joined Microsoft, I joined to in the developer relations team, and I was doing the Java team over there.
Hmm.
And then in 2020, Jesus, I can't remember anymore. I think no, it was 2019. By the end of 2019, I moved to the developer division where we do products and tools and services for developers, and that's where the Java engineering group sits. That's where I work now.
Hmm.
Since then.
We did the first episode in 2018, Microsoft Open Source Java. This was the episode number 15, and the next one was episode number 29, actually, 2019, later. And I think the last time was Bruno loves YAML something, and hates YAML, and not loves. This was
Who doesn't?
yeah. This was the May 2020, in the year 2020. That was the last one.
Huh?
But
That's a lot of episodes.
yeah, but one of the episodes we had a chat about servers versus runtimes, and this was actually for me really important, insight, because for me there was no distinction between both. I didn't care. When after our talk, now I'm more careful, talking about runtimes or servers. So and
Interesting.
yeah, because many people care, and something like Quarkus, right, is more like a runtime, and something like Payara is more a server. And
Yeah. Yeah.
and from architectural point of view, is a huge distinction right now. And yeah, this is what I wanted to tell you, since our chat in the AHEX FM podcast. I'll really be more careful about talking about servers and runtimes, and mostly I talk about runtimes right now. But actually, what I'm doing are all runtimes. So this was a great conversation, by the way. So this was the last time.
So interesting because yeah, the other day was I think it was Friday. I recorded another podcast with John Galloway, and we were talking about Java, the language. I had Mark Hagler also join, and we were discussing about. So John Galloway is a .NET guy. He has been doing .NET since .NET was born, but he was very curious about Java. So he invited me to his podcast, and I invited Mark because Mark also knows Kotlin, and I felt like the Java ecosystem is more than just the Java language or the JVM. So I needed some help, and Mark said, "Yeah, let's do it." And one interesting topic that came by at the end of the podcast that I raised to John, hey John, we should record this idea in the future, and it is that I think nobody should be fighting about languages anymore whatsoever. Languages. There are, of course, there are some aspects of programming languages that are important, like verbosity, type safety, uh, whether you can use space to make blocking codes or whether semicolon is important. Yeah, there are things like that. But really, when it comes to benchmarking and performance, it's not the language; it's the runtime. And oh, but I write this code in Scala and the code runs super fast. Well, it's Java, right? It's the Java runtime at the end. Scala compiles to bytecode, and the runtime is the JVM, it's the hotspot JVM. Sure, Scala code may produce some bytecode that is a little bit different than has more instructions or more structures than if you're writing Java or if you're writing Kotlin, but it's still the same runtime. So, and then people say, oh well, I'm coding TypeScript, but I'm coding JavaScript. Well, but it's Node.js, so it's V8. Your runtime is V8. So when people do benchmarks, I find odd that people are comparing languages in the benchmark when in reality they should be comparing the runtimes. I can write code in Rust, but run as a WebAssembly application. I can write code in Visual Basic and compile to bytecode that runs on CLR. Mm-hmm. So I think runtimes versus servers and runtimes and languages, it's an interesting discussion because developers get so attached to a topic and then they start comparing things, but not looking into actually the core of the thing that they are comparing or they want to compare. And that's why sometimes there's so many like wasted time in discussions and debates. And, when I look into these threads on Reddit and people are like, no, but you are wrong. And then, well, you're wrong because you're actually thinking this way. I'm talking about that way. And it's just a waste of energy and time and opportunities for people to actually like debate and come up with some ideas and, build something greater, or just become aware of things that already exist. So, yeah, that podcast ended with that open question. And who knows? Maybe in the future, that's another 1 hour, an hour and a half long podcast just to talk about runtimes.
So, okay, we can continue here because what we talk about is less about the performance rather than deploying or not deploying. So,
or the execution model.
Yeah, right? The application servers. Whether we should we have the war in deployment. I say, okay, I don't care, and I say, okay, but look, this is the server, and runtime means that is the Java starts the entire thing. And I thought about it, like, okay, you are actually right, and this was the idea. But back to your performance, I'm actually different opinion, but for other reasons. So performance usually doesn't matter a lot because usually it's fast enough if you write simple code. This is if you know what you are doing. I mean, if you know what you would like to write from the domain, business, or functionality perspective, your code will execute well these days. So I don't expect that it will run on .NET really fast and Java will be orders of magnitude slower. And whether something is 10% or 5% faster or slower, it really depends. I mean, you cannot say in general that .NET is in general faster than Java or Java is in general faster. Maybe there were some use cases when one is faster than the other, but it doesn't matter. But last year I reviewed a project, and it was a microservice project. But actually I reviewed two projects. There were two teams. One was like a very new team, and the other one was like developers who known each other for years. And the older team, they created everything in Java. Simple code. I read the code and I knew what's going on. So I knew it will run okay. And if it doesn't run okay, there is probably locking in a database or something, which has nothing to do with Java. And the other team by developers from different companies, and it was microservice architecture. They had no kidding. So the older teams they wrote maybe 5 microservices, which makes sense, and the others they wrote, I would say, maybe 40 microservices, and they used JavaScript and TypeScript in different microservices. So this was JavaScript was one microservice, the other one TypeScript. They used Python, they used Java, they used Go. And other languages, I forgot about this, but this was the languages I counted, and never saw such a thing. And I tried to understand what's going on. It was almost impossible. And I asked them, and they say, yeah, there was one developer from this company started in Python. We had no idea it was Python. Then we tried to do something with Go, and this is a mess. So I don't believe in polyglot programming in one team at all. So I would say if you are a .NET developer, just do .NET. And if I were, a .NET developer, I would probably just use C Sharp. I would not allow in my project, to have C Sharp, F Sharp, and whatever sharps you have. Just one sharp is enough. And in Java, exactly the same. What I try to do is, my personal opinion is Java 17 is good enough. Kotlin is maybe nicer, but it's not like if you write in Kotlin and I'm in Java 17, you will overtake me, by orders of magnitude. Maybe you are 5% faster. But now, if I'm using Java 17, I don't have, to justify why I use Java 17 and not Scala. But if you start with Kotlin in larger project, then you have to talk, we use Kotlin, but not Groovy and not Scala and whatever is, and the I would say, how to call it, alternative JVM languages. I wrote actually a blog
Right.
post because every 2 years I get asked, why you're not using actually Jython? You don't like Groovy, or why you're not using Groovy? Why you're not using Scala? And I say, okay, I don't care. I just, Java is good enough, and I do Java. And the last 20 years, it worked great. So I would say what I don't like is just picking another language because you are bored by Java. I would say then it means, there's enough excitement should be, in your project. So switching languages is like, if you are a butcher, and your job is, to sell sausages. It's not like you are experimenting with chainsaws and knives and whatever. It should be good enough, It's just a tool, and this is what I'm thinking. So I would say I'm completely with you with the runtimes, but I really don't understand why a project has to use 5 different languages just to have more fun.
There was a there is this project called Dapper uh, on the internet. Microsoft started that project.
Mm-hmm.
It's open source, and now uh, there are other companies contributing to that project. And one of the key things about that project is that it's a microservice framework that is actually polyglot. Where you want to talk to a database, well, you actually consume a sidecar that gets deployed with your application. Um, and you can write your application in Java, JavaScript, Python, whatever. And then from that application, you actually use Dapper SDK, or you can do a raw HTTP connection or gRPC connection to the Dapper sidecar, and the Dapper sidecar actually connects to the database or other components like messaging queue systems and whatnot. So Dapper abstracts that connectivity, and for some good reasons, you now centralize the access point between the application and those services. So and there are other reasons why that is an interesting approach. But the reality is one of the values that I saw people saying, "Oh, this approach is awesome because now different microservices can be written in different languages." And I'm like, why? Why would you have a company with and I'm talking about a small to mid-sized company. Why would you have a company have 5 teams developing a system, a product, and having like super diverse, fragmented choice of languages to implement that system? What good will that do in the long term for that company? Now you have to hire from different pools of developer markets, different programming languages, different experiences with other frameworks and whatnot, and it also limits the transition of employees between teams. Oh, I don't want to go to that team because they work with Java and I'm not a Java developer, so that I don't want to transition to that. I don't know how to help them or maintain that code because I'm a Python developer. I don't know Java and I don't want to learn Java. And I've seen that. I've heard those stories. And it goes both ways, right? I'm a Java developer, TypeScript or JavaScript is not my thing. I don't want to do Rust, or I don't want to do Go or whatever because Java is enough to me. So there is this sense of like, how these companies can have a workforce where knowledge can be shared. The moment that you have more standards or common choices among engineering teams, it is easier to share knowledge. You have more people using the same technologies, more higher potential of having better code review and learning experiences and modernization and evolution of the code base across different teams because of that, because everybody's sharing the same common technology choice. But for very big corporations, it's totally fine because there are multiple systems. There are lots of systems being implemented in a large company, and that happens. You go to a telecom company, they have hundreds of projects over there,
Yeah,
hundreds of systems.
but then we are talking like on the ESP level, which was we tried to achieve 20 years ago, where SOA coordinates the departments, right? This was the the idea. So, but I'm absolutely with you. If you're a huge company, the departments are almost like independent companies. So they could
Yeah,
be that one
yeah.
department uses Python, the other uses Java. It's fine, but I see no reason why someone in the Java department should introduce just for fun other languages. So if this is Java department, stick with Java, and the other department stick with Python. And then they can integrate over Dapper. So Dapper as a integration layer is perfect. So, but what I never understood, and this started, I don't know whether you remember, this. I think Craig McClanahan, right? The Java server face guy from Sun Microsystems back then started to talk about polyglot programming. I think back then that we should, pick different languages, and I never understood the idea to propagate the variety because in Java we were very strict about formatting and standards and patterns or whatever, and now we are talking okay, we could do everything there in Java, but I know why we should actively introduce in a Java project another language. This didn't never made a sense for me. Of course, if there is a talent, you are buying external companies and you get .NET developers, they should stick with .NET and we can integrate with Dapper or REST or whatever. So you should not migrate the .NET project to Java. They can just communicate, right? And this is of course, but I would never try, to introduce to .NET developers one Java microservice just for fun. Why? I mean, it is perfect if I would say the less complexity and having multiple languages in one project, of course, in my eyes, introduces the complexity usually, right? Because you have to understand more. You can use, you have to use different tools, different debugging, profiling, and so forth. So, long story short, there should be an obvious reason, to introduce more. How to
Well,
call it?
there is a reason.
Yeah.
There is a reason. Uh, one key aspect of retention of good engineers is morale,
Mm-hmm.
is excitement,
Mm-hmm.
is the opportunity to learn more.
Mm-hmm.
So if a mid-sized company or a large company with multiple departments, you know, they want to retain engineers, and if the engineer is happy because they can learn at the job, they can experiment with new technologies, and they are allowed to do their job with their choices of technology, as long as of course, you're not super crazy, but reasonable within what the company believes is the right set of technologies to be used. Uh, that actually helps the company and the employee to remain motivated, remain excited at the job, and the company to retain that engineer. So there is this personal aspect and motivational aspect that developers in general are always wanting. They always want to learn something new. They want to experiment new things. And what better way to experiment and learn something new if not in the job? And put that thing in production to test, and really go all the way to the finish line. So I understand this will to run these other languages, to build solutions in these other languages, because it is exciting. It is, you're exploring a brave new world of uncertainty and and discovering things every day. Oh my God, I can do this thing in Kotlin this way that I was never able to do in Java, and I still maybe am not able to do in Java. But I can do that in Kotlin. This is much better. Oh my God, I wish Java had that. That moment, that exact moment of discovery is what keeps engineers excited in doing their job. And that is an important aspect of retention of good engineers. And I see value in that. But there must be a balance. I'm sorry. There must be a balance of how far can engineers go to keep their excitement in the job while also reducing the risk of the company of not having a complete madness in the code base of their products and tech debt and other things that may make it difficult for the company to continually evolve and hire new engineers as well. So so that's why it's important to have some rules, some standards, some guidelines, some policies in place with architects and team leads that provide some north to the engineers so they can go a little bit off road, but still within the road.
Yeah,
You know, they,
I give you, yeah, absolutely. But learning new things, I'm entirely with you. But in the past, what I saw, and recently I saw, they wanted to use, in Java reactive programming. So they introduce a lots of new, APIs, and then I saw, 4 REST endpoints were invoked, and then wait forever, blocking call. And I was okay. I mean, nice that you did it, but with Java would be, a lot simpler, and we don't need external dependency, which we have to maintain. And I'm also my problem is if I would just take, let's say, Java 17, JDBC, and Postgres. Just this is what I would say almost legacy technologies. There is so much to learn. I would say you will need 10 years to understand what's going on, and you can still optimize everything from Postgres to Java. There is no need, Java is huge. Java SE even. And also recently I reviewed a project with crazy HTTP libraries, and they use Java 17. I asked them, why are you actually not using Java 11 HTTP client? It's just great. I didn't know about that.
right.
No, instead of using what's there, you are using external dependencies and crazy stuff. So my opinion is just start if you use Java. Learn Java first. This is really exciting. So the modern Java is really nice. So if I would deploy stuff to Microsoft, right? So on the cloud. So Dapr is Microsoft technology. So Microsoft technology is open source, but I take a look at the contributors, and Microsoft is very active. And what's surprising, most of the contributions happens in October. What is in October? A big conference. So it's always in October is like a spike of all the commits, but it is steady. And October is a spike, but it's still the entire year is very active, and October is a spike, or October, November, and so for me would be Java. If I'm on Azure, Dapr would be interesting because Dapr is like Microsoft standard. Why? Because most of the committers are from Microsoft, runs on Azure, is probably well integrated with the services. Stick with that. But I would then try to learn Dapr before I will try to introduce Istio, because I would say, okay, why I use Istio and Dapr for me are similar. Why to use Istio on Azure when Dapr is here? This is what I'm talking about, right? So in every ecosystem or runtime, there is a kind of a context or standard. And what I try to do is if I'm on Azure, I would use, Microsoft OpenJDK because I'm on Azure. Why I should, look at something different just to make, and I'm on AWS, I would pick Corretto because I'm on AWS. So I wouldn't get, the
Right.
idea to deploy on AWS Microsoft JDK. So this is what I'm talking about. Because if you think about this, Bicep and Azure functions, and there are already a lot to learn. I'm not really interested to even learn more. It's not like we everything is boring. So if you do it right, I would say if you push an Java application to Azure, so what you could do, you could be very conservative and say I use microprofile is well supported by Azure. So we say okay, then we can skip already 80% of Java frameworks. And then, integration with Azure Vault, config Azure functions with your Maven plugin. And I would say you can spend months just learning new things and still be very conservative. And you can sleep better because if you're using supported software, the chances are lower that something breaks. You know what I mean? If I would use Dapper, my expectation would be at least the certificates are working, But if I do something else, you did properly something with the cloud, right? Already. So the pain with configuration, certificates, and config. This is the, and not configs, port firewalls and permissions. This is this is always the complexity.
But it isn't. But that is sort of there is sort of a trade-off here.
Mm-hmm.
There will always be complexity. The question is, do you want to address the complexity at the beginning or later?
Mm-hmm.
So when you're developing an application, like you said, I just want to write a little microservice, and I'm gonna do Postgres database. So I need JDK 17. Postgres database is already running somewhere, and I need HTTP server. And then you may say, sure, use the HTTP server that goes into the JDK 17. I would never suggest that because it's not very well maintained per se for production. Doesn't necessarily provide the controls for production scaling. But let's assume you bring in at least one dependency, which is a microservice REST endpoint framework, whether it's MicroProfile or whatever, Jersey, whatever. Okay, fine. You develop that, you run that, and it's running with Postgres. Okay, now that is in production. Now you have, at some point along the way, new requirements. Those requirements are, okay, you need some logging, you need some APM solution, you need scaling this, you need to provide authentication and security, and authentication and security that will dynamically change with the application running. So you need to check an Active Directory or LDAP instance. Now your requirements start to evolve as your application is running. So you will have to deal with that complexity anyways, unless of course you are writing a lunar module landing system that the only job is to land on the moon.
No, but
the code came to. But my point is, business applications will always have requirements shifting along the way.
Yeah.
So
to this point, Bruno.
When people deploy applications to cloud environments or managed services environments, and they combine with service mesh or API gateways or identity services or whatnot, they already have those requirements. It's just a matter of time when those requirements will be enforced, whether it's at the beginning of the product development, whether it's at the time it goes to production, or whether it's the time that the application needs some scaling or some adjustments later on while in production. So the complexity will exist. It's only a matter of when you're going to address that complexity. On day one, when you start writing the code, or on day 500, a year and a half later.
Okay.
But it will happen.
My thinking is, so if you get, let's say Azure, because you're working on Microsoft, so we can talk about Azure now. So let's say my company did already the decision, we deploy to Azure. I would write a simple code. If you mention monitoring or logging, the first thing I would do, I would look at Azure Monitor. Why? Because I'm running on Azure anyway. So I wouldn't, start my exploration and try to find a crazy library to keep me busy. I say, okay, I would like, just to deliver the application, and I'm on Azure, so I would push Azure Monitor. If I would like to mark infrastructure as code on Azure, the first thing I will do, I will pick Bicep. Why? Because I'm on Azure, right? And any deviation from I would start at least with something what is there. And if this doesn't work, then I will pick something else. So this is the only thing. But if it works, I will learn a little bit more. And I guarantee you, if you start a fresh project with Bicep, Azure Monitor. I forgot the logging solution, log Analytics or something. It's called, right? The log aggregate on Azure, Log Analytics, I think is the name. And if you just then Azure App Service or container apps, and then you can, and then it doesn't matter which web server you're using. Let's say microprofile is Quarkus, but I know it will work. But we get a solution with these services, and we are already busy with new technologies. And I guarantee you can spend years to understand whatever we build here, if you would like, if you are eager to learn, and if you will introduce even more libraries on top of that, then I will start to question, what are you doing here? Is this just a fashion-driven development? So, I mean, is this not like, it's not enough to learn? So why we have to introduce another crazy technology on top of this, what we already have, right? This is just what I'm saying. So there is enough room to learn, just to know what we have. There is no need to add more. But I think we are almost on the same page. And back to Dapper is what I wanted to ask you, really. For me, Dapper is similar to Istio, right? So from the, it's also sidecar or service mesh, so it's similar technology to Istio, right?
Well, I am not super experienced with Istio. Uh, I don't know. It does sound like Istio. People mention that all the time. But honestly, the way I look into Dapper is I look at polyglot Java EE in the old days
Yeah,
with
Corba.
remote
So,
EJ.
mhm,
Exactly, with remote EJBs all the
mhm,
time.
mhm,
There's and uh, and the thing to think about Dapper is the components that actually make the connection to your endpoint services is oftentimes written in Go
mhm,
and with performance in mind
mhm,
for scalability. Um, so So if there is a problem of performance, you have to look into two places now. You have to look into your code and how it is talking to the Dapper sidecar, and you also have to look into the Dapper components that actually communicates with the endpoint. Uh, so that is there is some extra complexity now if a system is designed with Dapper or with any other framework like Istio. Now, what I find amazing is that when I started developing Java EE in the old days of 2000, around 2008, between 2008 and 2012, I was heavily working with Java EE and a little bit of Spring as well. And I found that people were already complaining about the complexity of things.
yeah,
Oh, Java EE and JNDI
yeah,
and JDBC driver and what driver to use. Do I use XA data source
mhm,
or no XA data source? What about authentication and oh my God, it was like so much. And then Oracle and other companies like IBM had all these solutions for SOA suite and API gateways and enterprise service buses and all of that. Like Red Hat also had great portfolio on that. Then MuleSoft came
mhm,
about and revolutionized the world of enterprise service bus. And I'm like, I mean, I found all of that amazing, but at the same time super complex for large systems. And then today, people are still doing the same thing. Complexity, will always be there. There's this say things start simple, but as they evolve, they will become complex no matter what happens. They will
mhm,
always become complex. Complexity is the end goal at
yeah,
the end of the day. And then it restarts. It restarts with somebody saying, no, enough is enough. Let's start again.
yeah,
And then they start a new
exactly.
project, they start a new technology or a new programming language. And at the beginning, everything is fine. But then eventually people start complaining, oh, there's this feature doesn't exist. What about that feature? And then suddenly those things are added, and then suddenly it becomes complex again.
Yeah,
So so the reality is I think technologists, software technologists, simply at large, there is a very small set that are comfortable with status quo, but the majority always want to do things differently, better, or more complex, or add more features, and then eventually they just go back and start complaining again and again. It's a vicious cycle.
Mhm.
It's one of the few industries that I feel that there is this vicious cycle of reinventing itself all the time, not because it must, but because it wants to.
Exactly.
And and I kind of agree with you. I mean, there are some technologies that are enough. Linux uh, is enough for server. Java is enough for a majority of backend systems. But we have to recognize the human aspect of working with software, working with technologies like this, that we get bored. The average person gets bored easily. And to remain excited in this world, in this industry, yeah, I mean that's like I think it's part of it. It's
Mhm.
part of the culture. It's part of the way that we think as technologists. We just accept it, and I think the more we accept, the more we understand, and the more we participate, perhaps in these new waves of new reinventions.
Yeah, but
You
then
know, start
we should
stop
include
fighting about.
we should include this aspect of boredom into agile cycle. So unit test red, then improve it green, then introduce something which makes it more exciting. Red again, then green, and then you are excited, because really. We do everything, Client says, okay, agile is, is say, okay, we do whatever necessary to make it work in production. And if you would take it seriously, the entire agile programming, then most of the project would really boring, because there is not like everyone is building a moonlander, what you said, right? So I would say then we would get just the requirements, we would write really simple code, and we would be done. And so this would, you have to be honest, to your client, say, okay, look, I would like to experiment. So, okay, then, I mean, to do some research, but this has nothing to do with my requirements. This is what I'm saying, because I do lots of task forces and code reviews, and what I see is really sometimes exactly crazy code, and I ask, what is that? What happens? Like, yeah, when we try to do something, is okay, and is okay, then I understand, but it doesn't make any sense now. And so back to Dapper. So I was now not really sure. You like Dapper or you don't like Dapper? So I mean, for me, what I took a look at this, and for me, I would say there is one killer use case of the entire Dapper for me, which is very obvious, is encryption and certificate management. This is always, a little bit problematic with the encryption from service to service. And if Dapper solves
Right.
this for me, then it's golden. This was exactly only one use case I knew from Istio is SSL. So I got to know. People ask me, what's your opinion about service mesh? I said, I don't need it. So the only thing I can imagine is, the encryption. This is what I would start with. And if you already have it, then we can talk. Maybe it can monitor a little bit and do stuff like this. But I was just curious about, because the Dapper is a sidecar and Istio is a sidecar, but I think Dapper does more, because to my understanding, there's like a gRPC also calls behind the scenes, and Istio is more or less like a network router with configuration. This was my understanding. But
Hmm.
if I would say, put it this way: if Dapper is really integrated, and I don't see this a lot, then I don't care, right? I don't like to deal with another thing which is a moving part. This is the thing. There has to be a significant added value to this. If there is no added value, keep it simple.
Yeah, I think Dapper can be a piece of technology that uh, that becomes part of a PaaS, platform as a service solution.
Exactly.
Like it's like built in,
Mhm.
right? It is not today. There's no Azure service that provides Dapper out of the box. We might have, I'm not super sure, we might have services internally that are using Dapper. I don't even know right now. But given that we have enough engineers contributing and working with Dapper, it is likely. But my point is, today I don't see that. I look into the Azure.com website. I don't see Dapper as a managed service. I don't see services announcing that customers can use Dapper as a built-in feature. But it could. Dapper could be part of a PaaS solution, especially on top of Kubernetes. That here's my application, and your application is designed to connect to the database through Dapper. And and the only thing, the main thing that I don't like about Dapper is that now your application code has to be Dapper specific.
Mm-hmm.
You want to talk to the database, you will not use JDBC.
Mm-hmm.
You will use gRPC.
Mm-hmm.
You will use or HTTP. You're gonna talk to the database through Dapper. And there is a fundamental challenge there. Developers are not used to talk to the database over gRPC. They're used to talking to the database through JDBC, through Hibernate, JPA, Juke, and MyBatis, and a bunch of other Java technologies that have been in the ecosystem for more than a decade. So now if a team says we're gonna use Dapper, and you have lots of Java engineers, well, in my view, you actually need whatever engineer, because now your engineer needs to know Dapper or needs to know how to talk to the database through Dapper. Mm-hmm. That to me is one challenge for the adoption of the technology, and for teams in general to think about this way. Mm-hmm. So that's that. There is an interesting approach to this model of application development with sidecars and whatnot. You said it well, like encryption and certificate management. Now my application doesn't have to do that. The data component will do that and talk to the database. Yeah, that is great. But honestly, is that something that is going back to complexity? It's a trade-off. You have to configure that at the beginning or somewhere down the road. I mean, and how often do we have to configure certificates? It should be once ever.
Oh, now it's interesting. What's your official title at right now at Microsoft?
Not production person.
No, but no kidding. It's like what's your title?
Product manager.
For what? For Asia or Java?
For Java.
Java. Okay, I thought you are more in Asia. So I was from the I was talking from Asia perspective. So now the truth is, if we talk on premise, I would never use Dapper. If I go to the cloud, it's a little bit different. And now the question is why I'm going to the cloud, right? Because there should be a reason. So it's not like all enterprise companies need hyperscaling. This is usually the workloads are running fine. So they are, I would say, a key advantages of cloud over on-premise. One advantage is, through the last 3 years, lots of companies run out of capacity, so they cannot. They have to go somewhere else. I mean, the only reason is to go to the cloud. So this is the asset story. But another thing is, strangely enough, security. It is really hard, to be highly secure on premise because there is no API. So if you would like to have, certificate rotation or whatever, it's really hard to implement this on premise because to automate everything is, I would say, almost impossible.
Right.
Encryption and rest and in transit, I mean, almost mission impossible. So then you can innovate, the next 50 years. And the next problem is, if you talk about security, at least in Europe, there are standards. And the truth is, the clouds are certified in all possible ways. So you cannot compete, with the certification with your data center with the cloud. So I would say security is the next one, right? And the last one I would say is disaster recovery. So I was in the last few years in projects where the expectation was, if one data center goes down, then the other will pick up, but the latency is the problem, and in Europe it's not always easy to find two on-premise data centers with a fast connection between them. You have to go to the cloud. So now, in such an environment, if we move to the cloud, for me, lift and shift an existing application to the cloud doesn't make any sense, because the cost will increase and there is no improvement to my clients. This is like refactoring without any business benefits, and everyone is disappointed in the shortest amount of time.
It depends.
Yeah, it depends. But it's in my context, in all my projects. So it's okay, because if you start and you just do the math calculation, Postgres database in the cloud, how much does it cost? How much the cost will explode, and
Right.
the expectation in Germany is that the clouds are cheap. I don't know why. I had a discussion with someone from El Salvador, Victor Orozco, I think. This was there was the guy from with Java Duke Adventures, and I had a chat with him, and he said, okay, in El Salvador, everyone knows that clouds are more expensive, but they are better. I'm saying, okay, in Germany, everyone expects to know what we are doing is cheaper than on premise. And then they see the first bill, regardless which cloud, and they are completely disappointed. So this always happens. And then I got, no kidding, everyone was crazy about microservices. So we shipped 5 microservices. And if you ship 5 microservices, the microservices are load balanced. And the manager saw the bill and asked, can we just not merge the microservices to a larger service? It will going to be cheaper, right? It's like, yes, but there's no more microservices. It's called monolith. It's like, I don't care, but the cost will be, lower. So I would say in clouds, there is a cost-driven development, right? So you have to justify the costs. They become obvious on the bill. And we had the discussion already, Bruno, with events. So if you go the serverless route, this is why I believe that serverless is the future, actually. If you go the serverless route, then you will see on the bill, pay-per-use, what costs how much. Of course, serverless is 20% more expensive, but at least this is visible on the bill, for what you are paying. Not like you pay the entire time for, control plane for Kubernetes. You just pay, per transaction, which is absolutely explainable to managers. Now, where I'm going with it. So we did in a project, actually on Azure, evaluation with Postgres. And if you do Postgres, you have to have the leader and follower and clustering and backup, and you have to do everything, which some developers may appreciate because the learners are like, okay, but if we go to the cloud, really, why we not pick Cosmos DB? I mean, this is the Azure native database, and they do everything for us. And then what happens then? It is cheaper, and now it comes. But if we pick Cosmos DB, there is no more JDBC. The programming model is different, and then I don't care whether I have to talk to Cosmos DB via Dapper or without Dapper. My JDBC is gone anyway. And for security reasons, also interesting. All cloud databases, Postgres in the cloud. What you don't get row level security. So you cannot say this row out of the boxes can be owner accessed by this permission. By the managed cloud databases, you get this. So what I'm just saying is, if you move your application to the cloud in cloud native way, maybe you could rethink what you are doing and say, okay, the clouds are different. So let's do it cloud native. What will happen if we will just pick, the cloud services really, and use the Microsoft Vault for certificate management, and not try to encrypt your certificates by yourself, let's say. And this is what I'm saying. And if you pick more managed services from the cloud, it is not like we have the APIs. They are not existing, right? This is what I'm saying. So lift and shift, I'm with you, but lift and shift, at least, in my project, everyone is disappointed because they say, okay, it is too expensive. Another thing what you mentioned is Kubernetes. I don't get Kubernetes in public cloud at all. So because for me, Kubernetes is the cloud, how cloud is built. If I run Kubernetes on Azure, now I have 2 clouds. I have the Kubernetes cloud, which runs on Azure cloud, and I have to, to fiddle with both clouds. So if I go to Azure, I will pick something like, I think it's called Container Apps. It's in preview right now. And what is normally in preview is Azure App Service. So we had a talk the last time about that. There's an Azure Container Instances, ACI. This is just one. Azure App Service, you have an orchestrator, which starts the containers behind the load balancer. And this is absolutely proprietary technology from Microsoft, but it is simple to configure. I've write, a few lines of JSON and I'm done. I don't care about, the tons of YAML. And if I have to go away from Azure to a different cloud, I will adjust the small JSON and it will work. So the entire, portability story with Kubernetes on the cloud. So for me, Kubernetes makes absolute sense on premise. In cloud, less so. So this is my personal opinion, my observations, because Kubernetes has own user management and has the configuration management.
Wait.
Yeah.
You say the future is serverless, but then you say that Kubernetes makes more sense on premises than in the cloud.
Yes.
It doesn't make sense. You're having those two beliefs, and let me explain why. One of the advantages of Kubernetes is having a place where it can orchestrate containers.
Yeah.
Right?
Yeah.
And by orchestrate containers, I mean not only just run them and scale them, but also secure them.
Yeah.
I can have control over the network and say where this container can connect to, talk to, internally, externally, whatnot.
Yeah.
I have full control of the network of the containers in my Kubernetes cluster. But I also have a almost serverless environment.
Yes.
If I am running Kubernetes in the cloud, I have a near serverless environment because I can grow my node pool in my cluster as I see fit, as I see the demand.
But it's not better than Azure functions. But Azure functions.
No. I'm talking just like horizontal scaling. If for some reason I have a system running on premises.
Yeah.
And I undersized my application.
Mm-hmm. On premise. Yeah, I'm with you.
Okay. I put something in production on premises. And then after I put in production, I realized I undersized my infrastructure. Okay.
Yeah.
What are my course of action? I can provision more servers and wait for them to be shipped, and then take months to have more hardware on my data center.
Yes, you're right.
Or I can demote other production systems, scale down, or scale in those systems so I can have more resources available.
Yeah.
But at the cost of those systems.
Yeah.
I'm limited. My
course.
options are very limited if I need to scale. Now here's the other thing. If I overscale, or actually if I oversize my infrastructure on premises and I'm using Kubernetes, how much money will I save if I reduce the number of nodes in my Kubernetes
Nothing.
pool?
You got me wrong. What I meant is, if you would like to build your own cloud on premise, Kubernetes is the way to go.
But that's the thing. No. That's the thing. One of the key benefits of cloud is being able to run your workloads and scale them and pay only for what you scale.
Exactly.
So if you have Kubernetes running on-prem, you don't have a private cloud. You have an on-prem orchestration system.
Yeah.
Of containers. That's it.
Yes.
That's it. There's no cloud.
How do you call it? I would say if you would like to orchestrate Docker containers on premise in larger environments, pick Kubernetes. In smaller environments, pick Docker Compose with Docker networking. It's not a cloud. I'm with you. But if you go to the public cloud, my point was Kubernetes is less interesting because Azure already orchestrates the Docker container as well, and does exactly the same virtualization.
It's also about the cost.
Yeah, of course, but I'm not pro.
Kubernetes has a cost.
Yeah, exactly.
A Kubernetes service has a cost. All right. Yeah. A Kubernetes service, whether it's on Azure, Google, Amazon, Oracle, IBM,
control plane.
Whatever, there is a cost of the VMs and the cost of the control plane.
Yes.
And some clouds don't charge for the control plane.
But most
for whatever reason, maybe they. Yeah, my point is, there is a cost of a managed Kubernetes service because the cloud vendor will patch the runtime, will keep the runtime up to date, things like that.
Mm-hmm.
And also the whole automation and provisioning of that service instance for you. But if the customer wants more value, which usually means have to do less things, they have to pay more. And they will pay more for Azure App Service. It's more expensive than Azure Kubernetes Service. Azure Container Apps is more expensive than Azure Kubernetes Service. Azure Spring Cloud is more expensive than Azure Kubernetes Service. But these services are more expensive because they provide also more value.
Yeah.
Now I don't have to manage Kubernetes, right? Now I get what you're saying. Lots of customers believe in that too, but also there are some customers that say, no, I know Kubernetes. The way that I manage Kubernetes, the way that I operate is different than the way that Azure Spring Cloud works, or the way that Container Apps works, or the way that
Sure.
App Service works. So that's why I want Azure Kubernetes Service. And I want Azure Kubernetes Service because I also want the sound value, which is, hey, Microsoft, provision me a Kubernetes cluster with these VMs,
Mm-hmm.
and I will schedule my system to grow at the end of the month because it's payroll time and whatever. I need to have more VMs in my node pool. And then once that is done, I'm going to scale in or scale down and reduce the number of VMs, and I'm going to save money, right? All of that. Because that company, that customer has good understanding of Kubernetes because they chose to.
Yeah, but I'm with you. But I also have such a clients. But one of my clients has to use Kubernetes and also uses on Azure, and they build products. And they say, okay, we already have the Kubernetes not orchestrator, how it's called, operator. Operator, and they have their Kubernetes specific investments, Helm charts deployments, and this is absolute sensible decision. What I'm telling you, if you are starting fresh greenfield, we said so we started a discussion just playing Java application with Postgres or something like this. For this, I wouldn't, in greenfield project, advise, to use Kubernetes. You say, okay, if you just would like to have a simple application, start with ACI. If you need something simple in cluster, use Azure App Service. And you will save a lot of time with fiddling with the configuration. And the newer service, Container Web App, I think it's called Container Apps, Azure Container Apps, I think is the name.
Yeah. Yeah.
Actually, it's Kubernetes behind the scenes, but I don't care. So you can use, in behind the scenes whatever you like, but I don't like to see it. This is exactly the same discussion. 10 years ago, everyone was crazy about OSGI, and Quarkus uses Glassfish was built on top of OSGI, and JBoss indirectly on top of OSGI, but I didn't care. So okay, I don't like to use OSGI in my project. It's too complex. If you use it under the hood, I don't care. Good for you, but for me, I would just focus on business. So and
I got okay. I understand what you're saying. So I agree with that. If it's a greenfield application,
yeah,
make it simple. Go to a fully managed service. Don't care about Kubernetes. Don't care about operators. But that is assuming the requirements are met, right? It's not just
yeah. But why I'm saying why I'm telling you this is because I get lots of requests regarding Java Cloud Native, and the first request is Kubernetes, and I always say, okay, why you need Kubernetes? And they say, yeah, because we think Kubernetes is cloud native. Everything which is not Kubernetes is not cloud native. This is usually a discussion where it's going on, and then sometimes I show them ACI, even Azure functions or whatever, and they say, okay, but this is proprietary Microsoft technology. I'm saying, yes, but take a look at the and the amount of configuration you need, for ACI or for Azure App Service, and compare it, to a Kubernetes deployment with your YAMLs and everything. And let's do a proof of concepts. And the funny story is, the managed services always won so far. There was for a typical microservice application in Java, there were no arguments, to use in my greenfield project. We talk about, a simple applications, to use the full portability and full power of Kubernetes, except the minority of my clients who had, significant investment with Helm charts and Kubernetes specific stuff, Kubernetes operators, of course. Why they should, migrate away if everything's already automated?
Right.
So what I'm saying is actually the Kubernetes is like what many of my clients did, back then, run, Spring on top of JBoss. I never got this because then I got, the dependency injection twice, the JBoss one and the Spring one. And Kubernetes is exactly the same. Kubernetes is own, user management. Azure has an user management, and I have to understand both. And for me, this complexity is optional. Before I do this, I would take a look what's there, and I could use ACI and so forth. But if I don't like go to public cloud, and I would like to create my own cloud on premise, then something like Kubernetes, but I would never pick, the vanilla Kubernetes. I would pick OpenShift or Rancher or something like this, and then I could build my own cloud. But using this is even crazier. What you said is not even, the hardware, but creating a right environment with the network and everything is not trivial. So I would rather spend, time with something different than managing my own hardware and the stuff. But this is a different story. What you just said is that Kubernetes shines if you create your own cloud. But if you are in the cloud can use Kubernetes behind the scenes. I don't care. But I don't like just to push my business logic, and this is somehow executed. And how is it executed? I don't care. This is back to our discussion. I would like just have my war or zip or jar or whatever, copy it over, and this basically it. And
it makes sense. It makes sense. As I said, I'm with you. Like, if it is a greenfield application, there's no reason not to try, understand, learn, and take advantage of new application deployment paradigms, right?
Yeah.
As you said, you use app service or use container apps. So that is the value of most cloud vendors. I was reading another tweet saying, "Oh my God, the cloud is getting complicated because now you have like 15 ways of doing the same thing." Well, that's fine. I mean, there should be 15 ways of doing the same thing because it's about choice. It's about a vendor providing different options to different types of customers and sometimes different teams inside a customer that are in different journeys. Some teams are maintaining existing systems for 5, 10 plus years. And now they have to go to the cloud because there is a mandate from the company. Hey, we are going to offset our data center and we're going to move everything to the cloud because we got this massive discount of like 40% discount on cloud infrastructure. We're going to take advantage of that. We're going to save a lot of money, but they have to go to the cloud. Okay, lift and shift of existing applications and starting now, all new development will happen cloud native. That is a quite understandable.
This is very understandable what you said. If you get a deal and you do lift and shift with as fast as possible, I'm with you. But the choice in the cloud is also interesting. So the choice in the cloud is important for costs because, as you said, there are higher level services and lower level services. And the cheapest possible service is how it's called VM set, right? It's the basic VM on Azure. This is the cheapest one, but you have to do everything by yourself. You have to patch, the operating system and everything, and in one point of time, it becomes more expensive than maybe ACI. And if you would like to have ACI with clustering, then you need, to care a lot with the clustering. Then you will pick Azure App Service, which is a little more expensive than ACI, but you do less. And
right.
This was the discussion. But we have, actually to interrupt because it's very interesting what you are building here. What you are doing, actually, Bruno, you are building a light or something like this, right? For your new Hollywood movie.
What? No,
you're creating. You had an interesting device. It was like a light, or what was it? It was a microphone, or what was it?
Oh no, this was. I'm just fixing, putting something back in the box to return. Yeah, stay tuned because we are going to publish some videos.
Okay. What I thought, this is like video light or something like this. Mm-hmm.
Yeah. This was a light for home studio.
Okay.
Which I need to return today as soon as possible. But,
okay.
But back to the discussion. I think people are starting to realize there's no. I mean, the Heroku model is interesting because it's simple, right? Yeah. DigitalOcean's model is also good because it's simple. I mean, if you go to those vendors, they only have a few options of deploying applications. but that also is a problem to them because now they also have less customers to provide value to because they have less options, right? By nature, and that's okay. Um, that's okay. I think that it's really the customer's job to find what works for them, what will fit their applications at any given point in time, and for us developers, our job is to find the right model for the right application at the right time with the knowledge that we have.
Well, sure.
So when you say, "Oh, you should go cloud native," yeah, we should. If it's a greenfield application, and I also have the time to learn, and my requirements are met, and but if I don't have the time to learn, guess what? I'm gonna shove Tomcat on a VM in the cloud, and I'm gonna manage it myself for a while
Yeah,
until I
you're
can
right. But we learned, half an hour ago that developers would like to learn. Now we have this is what
That's true.
what I
That's
told
true.
you. We can just learn with basic infrastructure. There's enough to do. There is no reason, to introduce third-party frameworks to make the life even more exciting. So this is the conclusion of our discussion today.
So the conclusion is we can
Do
we
whatever you
don't have
like.
to get we don't need to be bored at all.
Exactly.
There is a lot of stuff for us to learn. Okay, got it. Makes sense.
Perfect. Where people can
This
find you
was
on the
fun.
internet. Yeah,
People
it was
can find me.
fun. This time there was we discuss everything, but it is hard to summarize this podcast. It will be fun, to find a title. But I think it was good discussion around innovation and excitement and bigger projects and polyglot and
Yeah,
Dappers,
yeah.
Corba, Java, everything was there. The entire history of software
I think
development.
I think a good title for this can be finding some sense in a
In our job.
nonsense world, in a nonsense industry.
Okay. Oh, okay. I will try to reuse it. So, where people can find you, Bruno? Your Twitters and blogs
I'm on
and
I'm on Twitter. I don't blog much. When I have long stuff to share, these times I actually end up doing long threads on Twitter. But follow me on LinkedIn as well. LinkedIn.com/n/Bruno C. Borges. And on Twitter, it's just Bruno Borges.
okay,
And yeah, I do some stuff on GitHub as well. So github.com/Bruno Borges. Yeah, that's it.
okay, cool. So, thank you a lot. It was fun, and good
Yeah,
luck
that
with your
was.
light, bringing back your
Yeah,
light.
thank you. Thanks, man. This was fun.
Bye.
Appreciate it.